Cool, well, thanks everyone for coming along. This is pretty exciting. It's the largest meetup that we've ever hosted in San Francisco, so yeah, thanks for coming. I'm going to talk tonight about Docker in production, and we've got a great lineup of speakers, so I'll introduce them as they come up, but just a few sort of introductory comments. So I've got about 20 minutes of content here, half me and then half Kai, who's our developer evangelist. So when it comes to talking about Docker, I think we can all agree that Docker is awesome. It's fundamentally a better way of, it's fundamentally a better abstraction for packaging and deploying applications in a consistent way across your development environment, across the staging environment, and into production. But there's still work to be done because Docker's roots were in a developer-centric world, and developers tend to run applications on a single machine, on their laptop. But real applications, production applications, run on more than one computer. This is obvious probably to everyone in the room, but that it's important because being able to run on more than one computer means that you get reliability and means that you can get scalability. So there are sort of four large categories of problems that need to get solved in order to go from working really well in a single host environment to a multi-host environment. And the first one is composition. And that's true actually of single host environments as well, but composition is important because what composition means is being able to construct an application or a microservice or whatever you want to call it out of multiple connected containers. And of course there's a picture of a fig up here because fig is a popular way of composing applications. Scheduling is the second big sort of challenge, and scheduling is all about running across multiple machines or choosing which machines to run your containers on. And so composition is about multiple containers and scheduling is about multiple machines, and so if you have both, then you can run multi-container applications on multiple machines, and so we're getting somewhere. But then the next problem is networking, which is how do your containers talk to each other if they're on different hosts, and also relatedly, how do you know where things are? How do you do service discovery? And there's a lot of activity in this space. There's Weave, there's Socket Plane, there's Project Calico, and Docker themselves are also working on something. And so altogether, networking still remains not a completely solved problem sort of for the out-of-the-box Docker experience. And then finally, there's storage. And that's where we like to think that ClusterHQ comes in, because data is at the heart of every application, and yet you can't currently containerize and then operationalize databases in containers, because as soon as you attach a volume to a container, then that server that container is on becomes a pet rather than cattle. And in the cloud, we need to treat our servers like cattle, not pets. So storage is also a problem that needs to be solved. And so if you sort of squint like these four big areas, it feels like there is a solution coming together from lots of different ecosystem players, lots of different companies, lots of different pieces of the puzzle are being brought together. And I like this quote from Adrian Collier, a good friend of mine, that says, well, now I really want the Docker ecosystem to work to enable these solutions to get used together. And the example he picks is, I'd like to be able to use Kubernetes with Flocka and Weave. So that means Kubernetes, which would manage sort of your composition and your scheduling, with Flocka, which would manage your stateful containers, and Weave, which would allow them to all network to each other. And that would be great, except there's a problem. It's not currently possible to compose those different pieces of the puzzle together. And so sort of broadly speaking, the shape of the systems that we're seeing now look a little bit like this, if you sort of squint. There's some sort of orchestration and scheduling component. It might be a mesosphere or a Docker swarm, or another system like that is talking using the Docker Remote API to a set of Docker hosts. And that's okay, except then like networking people like Weave or Socket Plane come along, and storage people like us come along, and we're like, we really want to extend Docker in a meaningful way, but it's not possible because of this problem. Wrapping sucks. So specifically, in order for Flocka or Weave, for example, to do anything meaningful with Docker, it has to also take on the job of doing the orchestration, because at the moment, the only way to say, oh, I want to set up this, I want to get this volume in place before I start this container, or I want to set up this network interface before the container starts running, is to actually be the thing that's starting the containers. And so we end up with this situation where both Flocka and Weave, for example, need to have their own user experiences, their own command line tools. So you type Flocka deploy to spin up some stateful containers, or you type Weave run to spin up some networked containers. But that's stupid because you want networked containers with storage. So anyway, that's the problem. And so I've been working with some folks in the Docker ecosystem and Docker themselves on solving this problem. And one way that we've come up with to prototype a solution is to introduce a plugin mechanism into the Docker Remote API that sits on top of Docker and allows networking and storage plugins to sort of peacefully coexist. And I think that there are three things that are required for this to be a success. And this is good for Docker, and it's good for the Docker ecosystem, and it's good for everyone, is if these extension points, or if these extensions are late bound, meaning that you can plug them into an existing Docker deployment that you got from your operating system vendor. You don't have to compile them in, and because Docker doesn't have dynamically loadable libraries, that means that they have to be out of process. They need to be composable, which means exactly the point of what I was saying earlier, which is that you should be able to run two extensions at the same time, and they should work together. And they should be composable with orchestration frameworks like Swarm as well, and they should be optional, which is the standard sort of refrain of batteries removable, batteries included but removable. So if Docker extensions are to be truly optional, then Docker needs to use their own public extension points to implement their own extensions. And as I said, I think if we can pull this off, then we end up with a healthy ecosystem, we end up with lots of innovation around Docker extensions, and everyone will be better off. So the solution, as I mentioned, is a project that, or at least I shouldn't say the solution, I should say that a way of prototyping the Docker extensions mechanism itself is a tool that we've built called PowerStrip, which is a tool for prototyping Docker extensions. So the emphasis there is on prototyping. This is really just a way of figuring out what the actual Docker extensions mechanism should look like. And it's a way of sort of speeding up development of these vendors who want to build extensions without being bottlenecked on Docker having the extension points themselves. And so what it is a Docker API proxy that has multiple blocking pre and post hooks on arbitrary Docker API calls. And that allows a PowerStrip proxy to load a Flocka adapter and a Weave adapter side by side. And there's some probably more detail than I should have put in these slides about the actual PowerStrip protocol. It's very simple. You need to implement just one post endpoint, and you can implement an adapter that does anything, that takes like a container create command from the Docker API and does whatever it likes with it. It could pause the request, or it could change the contents of the API request. So it's a powerful tool for prototyping. And with that in mind, I'll hand over to Kai, wherever he is, over here, to talk just a little bit about the specifics of how you can compose Flocka and Weave together as an example. So thanks, Kai.
Hello. Yes, this works. Thank you, Luke. So yes, Docker in production, everybody is working on various tools to help run containers in production. Volumes, storage, and networks are two very important areas to do that. It would be great if we could have everybody working on their own solutions to these problems, and the keyword being composable, to pick and choose from all of these different solutions. So if you had one monolith that said, I'm going to do networking and I'm going to do storage, you're kind of locked into that one solution, and then a better solution to networking comes along, you can't just slot it in. So the real idea with PowerStrip is to enable people to prototype, develop, experiment, get it wrong, change their minds, and plug and play, slot Lego and change the shapes of that Lego to find the solution. So two tools that really do help volumes, Flocka, that helps with volumes. How does Flocka work? Well, it uses ZFS, which is a file system that takes snapshots. So you mount you mount a volume in a Docker container that is a ZFS-backed volume. And so really, Flocka kind of sandwiches containers. On the top layer, it's got a networking layer, such that you're not having to tell everything else in the application. You know, if we move the volume from one host to another, let's say the host dies or you're migrating is the good use case scenario, like, hey, my database is really busy, I need to upgrade the RAM or much more powerful CPU. Moving the state is a problem that nobody's really focusing on in production. You need to say, here's all my data, I need to get it from host A to host B. So how can you do that? Flocka is a tool that basically aims to solve that problem. The networking layer on top means that you're not having to tell the rest of the application, hey, the IP has just changed. The ZFS layer on the bottom is taking care of the snapshotting of the data. The container, your application that's writing to that volume, is in the middle. So let's think about how we can actually move a volume without a huge kind of break in service. Basically, the ZFS is snapshotting. You tell Flocka, I want to move this volume from this host to this host. The moment you tell it it's going to move, it starts streaming the snapshots of the whole volume from this host across, but it's not stopped the container yet. So it's moving gigabytes of data across. This container is still running. Everything looks like it's normal. It gets to a stage where you're ready to, it's copied that whole volume across. It's time to actually move the container. Because ZFS is taking snapshots, the final data you're moving is just the diff between that initial large amount of data. Then there's a small gap where you've said, okay, I want to actually move it. The networking layer kicks in and pauses any incoming connections, and you're moving the last little chunk of data, the diff. It's a couple of megabytes normally. I mean, it depends how busy the thing is, right? And so this moment that is paused is where that last little bit is moved across, and the container in your destination starts up, the networking proxy takes over, reroutes all the traffic. The rest of your application doesn't care. It's like, look, my database has come back, it's still got all of the data, and it's an upgraded, nice, big, fat server. So it's a great solution. It really kind of tackles one of the main problems that you're going to find in a production Docker setup, which is, hey, I need to upgrade my hardware, my database has got too busy. There's a lot more information on the repo, so I'm going to skip over how this works. We don't have a huge amount of time. Let's go to the next one, Weave. Weave is a virtual overlay network. What it lets you do is basically it works at layer 2, so it's speaking MAC addresses. It knows the MAC addresses of all the Ethernet cards. The IP addresses sitting on top, they can move around. So going with our example of Flocka, where we're saying, let's take a container here and let's move it. Let's not have to tell the rest of the application that that's just moved. You don't really want to have to rewrite where, you tell everything about this new IP. It would be great if the IP moved with the container, right? So Weave allows you to do that because it's a virtual overlay network. It's not a physical network where an Ethernet card has an IP, this Ethernet card has a different IP. Weave allows you to move the IP with the container, which is really, really handy, especially in our case, we're moving a database. We're not having to tell everything else about that change. It's just speaking to the same IP. So these two tools are really, really useful. How can we get them to work together? Because at the moment, they don't really. In this little picture, the ball is the Docker CLI, and everything is trying to say, I want that thing. You're not going to have that thing. It's mine. And how can you get these tools to work together? The answer is composing adapters. How do you get the adapters to compose? Well, PowerStrip is really, at the moment, the only way you can get these two solutions to work together. Otherwise, you'll say, I want just a Weave IP, it can move, or a PowerStrip, a Flocka volume, and it can move. But both things can't coexist if they're both competing over the CLI. So that's really the point of PowerStrip, is to enable you to A, prototype, and B, compose, and C, make it optional. Right. The two adapters we have, PowerStrip Flocka doesn't quite exist. I mean, give it 2 weeks, watch the ClusterHQ repo, and we'll go, there it is, there's the PowerStrip Flocka adapter. We're busy working on the API for Flocka itself to make that possible. PowerStrip Weave, was the first PowerStrip adapter that we launched. So that's there right now. You can download that, and it's quite easy to use. I mean, how do you configure PowerStrip to get these to work? It's a basic YAML file. You're hijacking Docker requests on the way through. So when you say Docker run, it's kind of two HTTP requests. It's create me a container. Here's all the information in the container that you need to create it with, and it returns an ID. That ID you then use to say start the container. So you basically hijack those requests. It triggers each of your adapters every time the Docker client is saying create this. In our example, Flocka would get told about that container being created. It would say, are there any volumes? Yes, there are. Mount a ZFS file system on that volume. Are there any IP addresses that you need for that container? Yes, there are. Do some magic. I won't go into the details of how it works, but I'll happily explain it afterwards. Allocate that weave address. In this case, weave is the only adapter that needs to know when the container started. And so, as you can see in the config, it's saying, when I'm started, tell weave about that container having been started. And it kind of kicks in and tells weave itself time to allocate the IP address. The real idea is that this is just one example of composing two adapters together. You can take any of the adapters and compose them how you like. You can hook into any of the Docker endpoints. So it's an opinionated example, but the real point to make is anything that Docker can do with its HTTP API, you can hook into with PowerStrip, and the config is quite simple. It's a YAML file. So again, I'll happily explain how both of those adapters work afterwards. Luke's going to give you a quick demo of how they go together. And yeah, it would be great to see some more adapters. So if this interests you, if you've tried to kind of get extensions working with Docker, it would be really, really great to sort of see some more adapters being written. So thank you. I'm going to scootle off, and Luke's going to give you a demo.
Awesome, and a shout out to Kai for actually writing the PowerStrip Weave adapter, which sort of kicked this all off. Cool, so a 2-minute demo now, and I thank you all for bearing with us during these opening remarks as they were put on the agenda. So I'm going to show you really, really quickly what you can do with Flocka and Weave composed with PowerStrip. And the demo is moving a crate.io database from one node to another, keeping the same volume and the same Weave IP. And this is kind of useful when you want to move stuff around. So just really quickly, we can see, hopefully you can see, that we've got two VMs here. They're two independent hosts. And on the top VM, we're running Docker PS. We can see that there's PowerStrip running. And so what we're going to do here is we're going to just use the regular Docker run command, unmodified, untainted Docker CLI, with a special volume that starts with /Flocka. And that refers to a global namespace and what's called the Weave CIDR, which is the Weave IP address. And so what happened when we ran that was that Flocka and Weave got kicked off via PowerStrip and got started, and Crate got started on that top machine. So you can see Crate is running there now, and Crate is not running on the second machine. So what we can do now is we can actually kill the Crate instance on the top machine, on the first machine, and then start a new Crate instance with the same volume and the same IP address on the other machine. And what we've done is abstract away storage and networking from the underlying infrastructure. And so you can see that Crate is now up and running with the same data that it had on the first node on the second node. So that's really whirlwind tour. Didn't want to take up too much time this evening, but the power of PowerStrip is that it allows us to compose multiple prototypical Docker extensions together in order to build more powerful solutions by sort of plugging Docker together with other bits of functionality in the ecosystem, and also then controlling these composed systems via your orchestration framework of choice. So for example, this could work with Docker Swarm or with Mesosphere. So that's everything. Just very quick reference to our GitHub. Feel free to come and check out the projects. They're all open source. If you want to follow us on Twitter, then please do. And we love hanging out on IRC, so it's #ClusterHQ for the Flocka stuff, and #Docker extensions for the official Docker extensions project, which we're proudly part of. And just to point out that we're also hiring in Bristol, England. If anyone from here is from there, I don't think you are, although I know you are. But also in the San Francisco Bay Area, which is very nice. So thank you very much.